Okay, today we shall be developing. Today we shall be, sorry, sorry, we shall be, we shall be developing unrestricted VAR model, restricted VAR model. That is our plan. We shall be developing unrestricted VAR model. Okay, so VAR model actually two type. One is restricted, restricted, and the second one is unrestricted. So one is restricted and the second one is unrestricted. Okay. Okay, what is the guideline? If the variables are not co-integrated after Johansen test of co-integration, then we can develop unrestricted VAR model. But if the variables are co-integrated, then we must develop restricted VAR model, and that is vector error correction model, right? That meaning that is VECM model. So that is the guideline all the time. And here we have three variables. You can see from here, that is consumption, GDP, and import. Okay, what I do, I make it zoom. I make it zoom. You can see all the three variables. So you can see consumption, GDP, and import. That is IMP. Then gross domestic product, then consumption. So we have these three variables, and the sample size from 1970 until 1980, 11 years data that we have. Okay, and what I do, I open all the variables as a group. I'm opening all the variables as a group. So here you can see all the variables, all the data. First is import, then is consumption, and third is GDP. Okay, and here we assume that all the variables are not co-integrated after Johansen test of co-integration. So as the variables are not co-integrated, we can easily run unrestricted VAR model, and that we shall be doing now, unrestricted VAR model, because the variables are not co-integrated after Johansen test of co-integration. And we also assume that all the variables are stationary. All the variables are stationary. That means there is no unit root in the variables. That also we assume. But if the variables are not stationary, suppose if the variables are not stationary, then we have to make it stationary first. Only then we can run the unrestricted VAR models. That means the variable should be stationary. If not, we have to make it stationary afterwards we can run the unrestricted VAR model, and that we shall be doing now. Okay, I go to quick, I choose the estimate VAR, and here are two things, unrestricted VAR and the vector error correction model. So I choose this one, the first one, unrestricted VAR, because the variables are not co-integrated. Okay, then here endogenous variables. So here I'm putting all the endogenous variables. We have three variables, GDP, then consumption and import, that is IMP. So we have these three variables, right? We have these three variables. So meaning that here after estimating there will be three model, and GDP would be dependent variable, consumption will be also dependent variable, and import, that is IMP, will be also a dependent variable. That means three model will be developed after running this unrestricted VAR model. And here suppose I choose here lag 2, lag 2. Suppose after doing the lag selection criteria advise me to choose 2 lag. So I follow that advice. And I take 2 lakhs. Okay, so meaning that 2 lakh is the most optimum for this model. So I take 2 lakhs, right? Okay, and the data is from 1970 until 1980. It is already here. Okay, now we can run the models, right? We can run the models. It is the estimation, you can see, right? You can see from here, estimations. Okay, estimation is here, you can see from here, right? Okay. Estimation is here. So here is the vector auto regression model. And here GDP is the dependent variable. Consumption is a dependent variable. IMP also a dependent variable. So there are three model. One is GDP, and second model is consumption. Third model is import. Okay, so suppose I talk about first GDP. You can see from here, it is the dependent variable, and all these things, suppose GDP lag 1, GDP lag 2. Why? Because here I have chosen 2 lag. That means every independent variable, will have 2 lag, and that is here, lag 1, GDP lag 1, GDP lag 2. Okay, in the similar way, I go down. That is also the second variable is what? Consumption, lag 1 and lag 2. Consumption, lag 1 and lag 2. Then the third endogenous variable, you can see import lag 1, import lag 2. And finally the constant, right? Constant. So that is our model, the first model. where GDP is the dependent variables. And you can see the same thing happen for consumption and also for import. Same thing is happening. Same thing is happening. Okay, here you can see, suppose I talk about GDP. In this GDP, there are how many independent variables are here? How many? 1, 2, 3, 4, 5, 6, and 7, right? So there should be 7 coefficient in total for each regression model. There should be 7. Okay. Okay, suppose I take this variable GDP lag 1, right? And what about this one? 23.8. 23.18 is the coefficient of GDP lag 1. And what about this one? 41.37. That is the standard error of this coefficient. 41.37. What about this one? The third bracket, 0.56043. That is the T statistics. Right? So here you can see this one. Standard error means second bracket, and T statistics means third bracket. That you can see from here, right? Okay. Now the question is that how to get this T value, that is 0.56043. Okay, what is the formula? The formula of getting T value is coefficient, that is 23.8, divided by standard error, that is 41.37. You can get the T value, that is 0.56043, and it will always happen. Okay, suppose example this one. What about this one? That is under our second model where consumption is the dependent variable. So here the coefficient is how much? 0.171. And what about the standard error? 0.166. And if you divide the coefficient, that is 0.171, with 0.166, that is standard error, you can get the T statistics, that is 1.02839. So that will always happen for all the variables here, right? Suppose this divided by this, you can get this T value, or this divided by this, you can get the T value. So it is for all. The same formula applies for all. Okay, then okay, suppose there are 3 models. One is GDP, one is consumption, and one is import. All you can see below. Below you can see all. Just go down. Go down. It is not here, I'm sorry. So okay, here what is happening? Okay, the thing is that here is my one question, that okay, here I check first one thing. One model has how many coefficient? 1, 2, 3, 4, 5, 6, 7. So every model has 7 coefficient, meaning that we have three model. That is GDP, consumption, and IMP, import. So in total, in the whole system, there should be 21 coefficient. That means 3 multiplied by 7, right? Each model has 7 coefficient, meaning that we should have 27 coefficient in the whole system. We call it VAR system, unrestricted VAR system. Okay, from this unrestricted VAR system, what is happening here? You can see. Okay, first suppose I have one question: whether consumption 1 is a significant variable or not to explain GDP. Whether consumption lag 1, is it significant to explain GDP? Yes. From the t value, we can know the answer, right? But if I know the p value, p, not t, if I know the p value, then I can answer better, easier if we have p value. But here is no p value. Here is all t value. Okay, what about the second question? Suppose GDP lag 2, that is this one, GDP lag 2, whether this variable is significant to explain import, IMP. How to know? Okay, the answer is from t value. From here, probably we can give the answer. But if we have p value, probability value, we can answer better. So what is the guideline? The guideline is, if the p value is less than 5%, then that particular variable is significant. Or if the p value is more than 5%, then that particular variable is not significant. So that is the normal guideline all the time. So here we got to know the p value. Then we can easily answer very fast. Our life will be easier to explain the answer if we have p value. Okay, so now the question is that how to get the p value? How to get the p value or probability value, right? How to get it? Okay, in this system equation. Okay, we can get the p value easily from here. Okay, how to get it? Okay, what I do? Okay, how to get the p value? Okay, I go to proc. Then I go to make system because it is system model. So I take make system, then order by variable. I choose this one. Okay, you can see our system model. Okay, we have three models. One is GDP, and the second one is consumption, and third one is import. Okay, so here you can see C1 actually the coefficient of GDP lag 1, and C2 is the coefficient of GDP lag 2, talk about C3 is the coefficient of consumption lag 1. C4 is the coefficient of consumption lag 2. C5 is the coefficient of import lag 1. And C6 is the coefficient of import lag 2. And finally intercept, constant of the first model, that is under GDP. Okay, then the second one, okay, the first one has been ended at C7, so second one will begin from C8 because it is system equation model. They are linked with each other. C7, so it starts with C8. What is C8? C8 is the coefficient of GDP lag 1. Then C9 is the coefficient of GDP lag 2. And the whole thing actually ended here, ended at C14. So meaning that the next one should begin from C15. In this way, the last one is C21. So meaning that it has started from C1 and ended at C21. So it can estimate 21 coefficient. It can estimate 21 coefficient plus 21 p-values. So here I am telling again what is happening. Here she can estimate 21 coefficient, so meaning that she can also estimate 21 p-values, and that we shall be doing now. Okay, how to estimate all the coefficient? How to estimate all the coefficient? That is the question now. To estimate all the coefficient, I go to estimate, right? Here is a icon, you can see. I click on it, and here they are talking about estimation method, and that is ordinary least square, meaning that OLS, right? And we can use it. We can use the OLS method to estimate the system equation. Okay, then I press OK. I press OK. So the result has come up. You can see the result, right? The result has come up. The result of the system equation. I'll just make it big. I'm sorry. I make it slightly big. Okay. The result of system equation has come up. You can see from here, right? So meaning that you can see here that just make it. I make it slightly big. Just 1 minute. Just 1 minute. I make it slightly big. Okay. So it is the result of the system equation. You can see system equation, right? So here are the 21 coefficient. You see from here C1, C2, C3, C4 until C21. So there are 21 coefficient has been estimated at a time. 21 coefficient has been estimated at a time. So the whole thing actually called system equations. Okay, and in this, just 1 minute, just double check one thing. Just one check. Okay. Just 1 minute. Okay. And you can see from here in this system equation, you can see suppose I talk about the first one, C1. What is C1? The coefficient. So it is the coefficient 23.8 divided by the standard error 41.37. So coefficient divided by standard error, you can get the t statistics. So that is the formula. Coefficient divided by standard error, you can get the t statistics, and 0.5955 is actually the p value, the probability value that we are looking for, right? Probability value. So in this way, you can see all the probability value for 21 coefficient. Suppose the last one, C21, the probability is how much? 0.9099, meaning that 90.99%, meaning that this particular coefficient, that is C21, is not significant because the p-value is very high. What about the first one, C1? Is it significant? So how much is the p-value? 59.55, which is more than 5%. So it is not also significant variable here. Okay, in this way, we can check all the variables, whether they are significant or not. Okay, now we can see some more things. At the below, you can see we have three models. The first model is this one, and here the GDP is the dependent variable, and these are all independent variable until C7, right? So that is the first model. And the second model equation, second model actually start with consumption. So consumption, it is C7, it start with C8, right? C8, C9, C10, C11, 12, then C14. That is the constant of this model. And what about the last model? That is import, IMP. What is IMP? Import. That is the dependent variable. And all these things are independent variable. So the last one is C21. What is C21? C21 actually the constant of IMP model. C21 actually the constant of IMP, meaning that import variable. Okay, suppose I check whether import lag 1, this variable import lag 1, is this variable is significant to explain our dependent variable, and that is consumption. That we want to check. Okay, I'm telling again whether import lag 1, is this variable is significant to explain our consumption. Okay, so how much is C12? What is import lag 1? Import lag 1 means C12, right? C12. So we go up to check C12 and we check the p-value of C12. P-value is how much? 49.37%, which is more than 5%. So it is not a significant variable. Okay, in this way, suppose we can take this one. Suppose I take, suppose C3, suppose consumption lag 1. Consumption lag 1. Is it significant to explain our GDP? Okay. Consumption lag 1 means what? C3. Consumption lag 1 means C3. Is it significant to explain GDP? Right? Okay, I go to C3. That is C3. And what is the p-value of this C3? P-value is 48.79%. P-value is 48.79%, and which is more than 5%. So C3 is not a significant variable, meaning that I can say it is here C3 is not significant, meaning that consumption lag 1 variable cannot influence the dependent variable, and that is GDP. So in this way we can check all the variables individually, whether they are significant or not. Individually we can check whether they are significant or not. Okay. So here I'm talking about individual significance. What about joint significance? Joint significance. One is individual, right? And the second one is joint significance, right? Joint significance, right? Okay, what does mean by joint significance here? Suppose I want to check whether IMP lag 1 and IMP lag 2, these two variables jointly can cause the GDP or not. Whether import lag 1, import lag 2 jointly can influence GDP or not, that we want to check. That means whether import lag 1 and import lag 2 can cause GDP or not, that we want to check. Okay, to check it we shall have to use VAR test, right? VAR test, and that is called actually joint significance test, right? So we call it VAR test or joint significance test, or we can also call it world coefficient test, right? That is also another thing. So we can say about it. Okay, so we set our null hypothesis here. So here is our null hypothesis, whether C5 and C6 equal to 0 or not. That we want to check. I'm doing again. The null hypothesis is for this model, just I'm writing here, whether C5 equal to C6 equal to 0 or not. So that is the null hypothesis I'm doing here. C5 and C6 is equal to 0 or not. That is our null hypothesis. And if the C5 and C6, if it is 0, meaning that import lag 1 and import lag 2 cannot jointly influence our dependent variable, which is GDP. But if C5 and C6 are not jointly 0, that means if we can reject null hypothesis, meaning that import lag 1, import lag 2 jointly can influence GDP. Okay, that we do now. Okay, so we do the Wald coefficient test. So how to do it? Okay, I go to view, then I go to coefficient diagnostic, right? Then Wald coefficient test. So I put this two coefficient C5, C5 equal to C6, right? Equal to 0. That is my null hypothesis, right? That is the null hypothesis that we have set here. That is the null hypothesis. So I press OK. So this is the outcome of our result. It is the Wald test, right? You can see. And it is the null hypothesis C5, C6, 0. And it is the test statistics chi-square, and it is the p-value. How much is the p-value? 55.47%. 55.47%, which is more than 5%. So we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that C5, C6 is equal to 0. We accept it, meaning that C5, C6 equal to 0 means, just 1 minute, I have lost the whole things. Okay, it means that, sorry, not here, I put it where C5, C6, 0, meaning this, just 1 minute. Why? Okay, just 1 minute. Okay, just 1 minute. I do this. Just 1 minute. Just 1 minute. Okay. Yes, I come here. C5, C6 is 0, meaning that import lag 1, import lag 2 jointly cannot cause the GDP, or import lag 1, import lag 2 jointly cannot influence our GDP variable, which is dependent variable. Okay, in the same way, we can take, suppose, another example. Suppose talk about this one, import, that is the dependent variable. Suppose here we want to check whether GDP lag 1 and GDP lag 2 whether this variable, two variable, jointly can influence import or not, right? That we want to check. So here we have two coefficient C15 and C16, right? So we set the hypothesis as before. What is our hypothesis now? The hypothesis is here C15, C15 equal to C16. Are they zero or not? That is our null hypothesis. C15, C16. Okay. That is zero or not. We set the hypothesis. So as before, I go to view and coefficient diagnostic, then world coefficient test, right? So here I set the hypothesis C15 equal to C16 equal to 0, right? Equal to 0. So that is my null hypothesis. I press OK. So here what is happening? C15 and C16 0, that is the null hypothesis, and it is the wall test, it is the test statistics. What is the p-value? 62.38%, which is more than 5%. So we cannot reject null hypothesis, meaning that GDP lag 1 and GDP lag 2 jointly cannot influence the dependent variable, which is import, or GDP lag 1 or GDP lag 2 jointly cannot cause the dependent variable, which is import. So in this way we can check all the joint significancy test by using world coefficient test. Okay, so far we have done it. We have estimated this system unrestricted VAR model, right? We have already estimated unrestricted VAR model, right? And unrestricted VAR model, and we have three variables such as GDP, consumption, and import, right? That we have checked already. Unrestricted VAR model, GDP, consumption, and import, and this is the outcome of the unrestricted VAR model, right? And that we have already seen, right? Outcome of the unrestricted VAR model, right? That we have seen already. And here we have seen that we have three model. That is the first model, and where the GDP is the dependent variable, right? GDP is the dependent variable. And the second model is this one, the consumption is the dependent variable. And what about the third one, import, right? Import is the dependent variable. Okay, now we want to check whether individually, now I talk about individually, whether individually, suppose I take GDP, individually, how is this model? That means diagnostic checking. Individually, how is this model? That is meaning that GDP model, right? Okay. So what I do, okay, and also I shall check individually how is this model. That is where the this one is the dependent variable, meaning that consumption is the dependent variable. And also I shall check individually how is this model. That is import is the dependent variable. So first I start with this one, GDP. Okay, what I do, I make a selection, right? I make a selection and I copy it. I copy the whole models. Okay, I copy it. Then after copying it, after copy the GDP, then I open quick, then I choose estimate equations, and here I paste it. I paste it whatever I copied. I just paste it. I choose the paste, right? I paste it. The whole thing has come. So now I set the things so that I can estimate it. I set it like this. I set it right. I set it like this so that I can estimate it. Okay, set it. Okay, I've set it right like this. Right, meaning that I'm following this setting. You can see Y C1 C2, right? I follow this guideline that is given here, right? And I set it accordingly. So here I can make it zoom so that you can see better. See, I have set it, the whole things. And here GDP is the dependent variable, right? And all are independent variable, lag 1, lag 2, right? So here I have C7, right? So this is my model, right? This is my model and so on, right? Okay, now I shall be estimating it. I shall estimate it. Okay, so I press OK. I press OK. Okay, this is my estimation of the model, right? You can see from here. Right? This is the estimation of my model. You can see the dependent variable is GDP, right? And this is my model actually, right? Okay. Now here you can see, okay, now I shall be doing the diagnostic checking. That means how is it as a model? Diagnostic checking. Okay, how it is as a model, that we shall do now. Okay, okay, first I check. Okay, and you can see the result. Okay, and you can see the result are here, right? This is the outcomes. Okay, okay, so here what about C1? C1 is the coefficient of GDP lag 1. C2 is the coefficient of GDP lag 2. C3 is the coefficient of consumption lag 1. And C4 is the coefficient of consumption lag 2. C5 is the coefficient of import lag 1. C6 is the coefficient of import lag 2. And finally the constant C7. Okay. and these are the outcomes C1, C2, C3, C4 until C7. So these are the coefficient. Okay. Now I check how many variables are significant here. So we can know it from p-value. From the probability value we can know it. But here you check all the p-value is more than 5%, meaning that none of the variable is significant. So that is a very bad side of this model. None of the variable is significant to explain the dependent variable, that is GDP. None of the independent variable is significant to explain the dependent variable, that is GDP. Okay. Okay. Then you just wait 1 minute. I'm just giving like just 1 second. Okay. Okay. Then I'm just saying that is okay. Then then what is happening here? Okay, so none of the variable is significant. Individually, that is a bad sign, very bad sign. Okay, then we can check jointly. Jointly, how many variables are significant? Suppose we choose consumption lag 1. Suppose I choose this one. Import lag 1 and import lag 2, right? Is this two variable jointly significant? We can also do it by the wall test, right? We can also check by the wall test whether import lag 1 and import lag 2 jointly can influence GDP or not. We can do it also, but how we can do it? How we can do it? So I go to the as before. So as before, I go to view, then coefficient as before. So here I can take the wall statistics as before. So I choose the I'm doing again. So whether import lag 1 and import lag 2 jointly can influence GDP or not. So we can appoint the wall test, world coefficient test. World coefficient test we can choose to get the job done. So the null hypothesis is import lag 1 and import lag 2 jointly can influence GDP or not, right? That we can do now, meaning that suppose we set the null hypothesis. The null hypothesis here that C5 equal to C6, I can put it 0, right? C5, C6 equal to 0. So that is the null hypothesis. Suppose we cannot reject null hypothesis. That means if we accept null hypothesis, meaning that C5 and C6 are 0, meaning that import lag 1 and import lag 2 jointly cannot influence our dependent variable, that is GDP. Okay, so I go to view to test it, then I go to coefficient diagnostic as before, then I choose wall test, right, as before, Then I set the hypothesis C5 equal to C6 equal to 0, right? Equal to 0. I set the hypothesis, right? Whether they are jointly 0 or not. So here you can see wall test, right? chi-square and the p-value and the null hypothesis. So here the p-value is how much? 55.47%, which is more than 5%. So we cannot reject null hypothesis, meaning that we accept null hypothesis, meaning that C5 and C6 is 0. Meaning that, meaning what? Meaning that we can see last time, meaning that C5, C6, 0, meaning that import lag 1 and import lag 2 jointly cannot influence our dependent variable, which is GDP. So what is here decision? Import lag 1 and import lag 2 individually they cannot influence GDP. At the same time, import lag 1 and import lag 2 jointly also cannot influence GDP. That means individually they cannot influence and jointly also they cannot influence. So that is the decision here. Okay, then I talk about other things such as I talk about R square of the whole model of this GDP model. R square is quite high, 86.37%. So we are happy about it. It is quite high, 86.37%. So meaning that the model is better fitted. Normally, if the R square is more than 60%, we are happy, but here 86.37%, so we are quite happy. So that is the good side of this model, but bad side is F statistics. You see F statistics and corresponding p-value. How much is the p-value? 35.54%. So 35.54%, which is more than 5%. So F statistics is not significant. So that is a bad side of this model, right? F statistics is not significant. Okay, then I check whether this model has serial correlation or not, whether this model has heteroscedasticity or not, and we also check whether the residual is normally distributed or not. Okay, I check one by one. I go to view, then residual diagnostic. First I check serial correlations, right? Because this one is the time series data, so probably serial correlation is there. Normally, if the data is time series, normally the time series model is affected by serial correlations normally. So I check it first. Okay, suppose I choose lag 2, right? Then I okay, so I choose lag 2. So the okay, suppose sorry, I've come here to wrong place. No, sorry, I've come to wrong place. Okay, I go to my model. Where is my model? I just go there, work files, because the data is not sufficient to estimate the estimate the serial correlation. Okay, I do it again, nothing to worry, I can do it again. The data is not sufficient, okay, no problem, I can do it again. Where is the models? Okay, just 1 minute. Data is not sufficient to estimate our data is only how many? Our data is only 11 or 12, right? That is not sufficient to check the just 1 minute, to check the serial correlations. So what I do, I try again. I go to view, residual diagnostic, serial correlation. Okay, here I took lag 1, not 2, right? Because our data is not sufficient to check the serial correlation. So I took lag 1, then I check. Yes. Okay, here the serial correlation, Bush-Godfrey serial correlations, observed R square and the corresponding p-value. How much is it? 83.29%. 83.29%, which is more than 5%, meaning that we cannot reject null hypothesis. And what is our null hypothesis? The null hypothesis is there is no serial correlation in the residual of this model, and that is desirable. There should not be any serial correlations. So we are happy about this model because there is no serial correlations. Okay, then we can check whether there is heteroscedasticity or not. And normally time series data do not have heteroscedasticity, but still we can check it. I go to view, then residual diagnostic, then heteroscedasticity test, right? And here I choose the first one, Bush-Godfrey test, right? The first one I choose, okay. And this is the Bush-Godfrey test of heteroscedasticity. And I choose this one, observed R square and corresponding p-value. What is the p-value? 29.47%, which is more than 5%. So we cannot reject null hypothesis. What is our null hypothesis? The null hypothesis is there is no heteroscedasticity and we cannot reject it. So we are happy about this model because there is no heteroscedasticity in the residual of this model, and that is desirable. So we are happy about the model. Okay, finally we can check whether the residual is normally distributed or not. That we want to check finally. So I go to view, then residual diagnostic, then I check this one, test of normality, right? So this is the outcome, and here is the Jarka-Bera statistics, you can see, and corresponding p-value, right? How much is the probability value? Here we can see the probability value is 79.08%. 79.08%, which is more than 5%, meaning that we cannot reject null hypothesis. And what is our null hypothesis? The null hypothesis is that residuals are normally distributed and we cannot reject it, and that is desirable, that residual should be normally distributed and we cannot reject it. So we are happy about this GDP model. Why? Because residuals are normally distributed. Okay, so I talk about this model, as a GDP model, how it is. Okay, number one, this model has no serial correlation, so we are happy about it. This model has no heteroscedasticity, so we are happy about it. This model residuals are normally distributed, so we are happy about it. This model R squared is very high, we are happy about it. But the problem is that in this model F statistics is not significant. So that is the bad side of this model. And second most important bad side, none of the individual none of the individual none of the independent variables are significant to explain the dependent variable. That is the greatest problem of this model. So I'm telling again, what is the main problem of this model? None of the independent variables, meaning that I can show you in this model, you can see none of the independent variable is significant. So that is the very bad side of this model. So we cannot accept this model as a whole because none of the independent variable is significant. So my suspect actually that this model is suffering from problem of multicollinearity. I guess this model is suffering from problem of multicollinearity, right? Multicollinearity, right? And that is why, because of this problem, none of the variable has become significant. That is my suspect, right? That is my suspect that here is a problem of multicollinearity, right? And I think if this problem is removed, if the problem of multicollinearity is removed, then I think few variables will become significant. But we have to remove it, right? Okay, so the GDP variable is done. Our first model is done, right? Okay, then what about our second model? Second model, I think that is the consumption model, and we can check it, right? We can check the consumption model about the consumption model. So meaning that this one, okay, that is our second model. To check how is this model as a model, how it is. So I copy the whole things. I copy the model, and then I go to quick estimate equations as before. I paste it here as before. Then I arrange it as before, right? Then I run it. Consumption, I set it, otherwise we cannot estimate it, right? Settings should be very proper, right? So that is my setting already, and I can zoom it for you. You can see the whole things. That is my second model, right? I set it already. That is the zoom, right? Okay, so now I can estimate it. Okay, this is the outcome of the consumption model, right? Okay, So here I check also what is happening here. I just set it. Just 1 minute. I just set it. How to set it? Okay, I just set it. Consumption model, right? I just set it. 1 minute. Okay, here you can see that our consumption model. Here you can see that. Just go down. Okay, you can see the first thing is that you can see the probability value. None of the variables are significant. So that is a very bad side, and we cannot accept the model. You can see all the p-values are more than 5%. So I suspect that there is a problem of multicollinearity, and and if the multicollinearity is removed or handled, I think some of the variables will become significant. So that is a very bad side of this model. We cannot accept this model. And secondly, the R square is very low, 59.95%. We are not happy about it. And the F statistics is not significant, right? That is a bad side. You can see from here. It is 78.44%. So it is not significant at all. So that is a bad side also. Okay, then I talk about the residual. I go to view, residual diagnostic. First I check serial correlations, right? Okay, here I choose lag 1 because our sample size is very small. So I choose lag 1, right? Not lag 2. Okay, here is the outcomes. You can see the Bush-Godfrey test, right? The Bush-Godfrey. You can see from here. I just adjust just 1 minute. I adjust it slightly. Not coming up. Okay, I do some adjustment. Okay, I put the p-value, right? Okay, here you can see here. Okay, okay, here is the Bush-Godfrey test. Observed R square, corresponding p-value. So so we cannot reject null hypothesis, meaning that we accept null hypothesis, meaning that there is no serial correlation. So we are happy about the model. Then I talk about the second one, residual diagnostic, heteroscedasticity, right? We check it. Okay, and we choose Bush-Pagan-Godfrey as before. Okay, and that is the result. Bush-Pagan-Godfrey, observed R square, corresponding p-value. So the p-value is not also significant, meaning that there is no heteroscedasticity. So we are happy about the model. And finally, I check the test of normality, right? That is the last test of the residual. And here is the Jarkabera statistics and corresponding p-value. So the how much it is? The probability value is 74.65%, right? Which is, so as a result, we cannot reject null hypothesis, meaning that residuals are normally distributed. So we are happy about it. Okay, so it is the second model. What about our last model, that is import? I check our last model. So I go to system equation, right? So that is our last model, right? Import is the dependent variable. So I copy the import, right? I copy it. I copy the whole things as before. Then I go to quick estimate equations and I paste it here. I paste it here, and then I arrange it. I arrange it as before, right? I arrange it. slowly. You have to arrange very slowly, otherwise you may face problems. So yes, it is done, set. Then I okay. Okay, it is the outcome of the import, right? The dependent variable is import, and here what is happening? See, you see from here, none of the independent variable is significant, meaning that here is a problem of multicollinearity, and r squared is also small, and the probability value is not significant, so we cannot accept the model because none of the independent variable is significant, so we cannot accept the model. At the very beginning we cannot accept the model. Okay, what is the guideline? The guideline is that most of the independent variable should be significant to become a good regression model. Suppose example, here is 1, 2, 3, 4, 5, 6, 7. So out of 7, at least 4 should be significant. Out of 7, at least 4 should be significant to become a good regression model. At least 4. At least 50 to 60%. At least 50 to 60% of the independent variable should be significant to become a good regression model. But here none is significant, so we cannot accept the model. Okay, then we check the residual matters. I go to view, residual diagnostic. Okay, first I check serial correlations, and here I choose lag 1. Okay, you can see the serial correlations. Okay, observed r square and corresponding p-value. Okay, what is the p-value here? 0.39%. 0.39%, which is less than 5%, meaning that we can reject the null hypothesis, meaning that there is serial correlation in the residual of this model, and that is not desirable because we can reject the null hypothesis. So there is serial correlations, and that is not desirable. So that is bad side of this model. Okay, then I talk about the heteroscedasticity. We check it. Okay, we take the observed r square and the p-value. The p-value we cannot reject, meaning that there is no heteroscedasticity. So we are happy about it. So we are happy about it that there is no heteroscedasticity. And finally we check the normality, right? Normality. Here the Jarkabera statistics, corresponding p-value. How much is the p-value? 80.58%, meaning that we cannot reject null hypothesis, meaning that the residuals are normally distributed, and that is desirable. So we are happy about it because residuals are normally distributed. Okay, this model has mainly two problems. Number one problem, that no independent variable is significant, so we cannot accept the problem. So probably there is a problem of multicollinearity. That is why none of the variable has become significant. And another problem of this model, or of this import model, I say that the import is the dependent variable of this model. Another problem uh, is that there is serial correlations in the residual, and that is not desirable. Thank you very much for being with me for a while. Good luck. The terms of uses, right? You can see.